Welcome to this Tech Talk, where we are going to be talking about building a chat application with AWS CDK and AWS AppSync. My name is Michael Liendo. I'm a senior developer advocate on the Amplify team, and I specialize in teaching front-end developers and back-end developers how they can best work together by building out full-stack applications. Now, in today's Tech Talk, what we're going to be essentially presenting are a couple of tenets that we have set up for us here. The first part will be developing modern applications. And what does this look like when you have split teams where the front end side focuses on what they're best at and the back end teams get to do the same? After that, we'll go ahead and transition to talking about some of the AWS services that really come in handy when we start to build out these full stack applications. And this is beyond what you may have in your to-do applications, hello world type applications. Moving past CRUD and talking about real-time application data flow. What does it look like when you need to respond to real-time events? And then to showcase all of those coming together, we'll have a demo and then wrap up with some final thoughts towards the end. Now, I do want to take a moment to talk about modern application development, as we just mentioned. What does that look like today, and how has this transitioned from what we may be used to 5 years ago? Well, in a nutshell, front-end tooling has really evolved, and some of the expectations of what we come to expect when we build out some of these applications have really taken off and have eased developer pain points. Now we have libraries such as React.js, and we'll be talking about that in depth, and that essentially makes up half of our full-stack pillar here. Now, the library that we'll use is React, but the framework that will encompass that is going to be Next.js. And we'll take full advantage of this, whether it be API routes, calling application data on the client side versus the server side, and vice versa. But then we'll also take a look at some of React's core benefits, such as encapsulated data within hooks. In addition, we'll also talk about GraphQL and how that differs from REST and why we might choose that instead. In particular, you'll see a scenario where we solve the underfetching and overfetching scenarios that you might have in RESTful applications. Now, core benefit of GraphQL really comes down to having this schema documented API. Front-end teams and back-end teams can take advantage of those, as well as non-technical members such as project managers, external stakeholders, and even your customers. Now, moving on from there, we have our UI library. Front-end developers oftentimes don't want to have to develop the same components over and over again. So instead, we'll take a look at how AWS Amplify helps ease that developer pain point by providing Amplify UI primitives as well as connected components. And then to wrap up the front-end tooling side of things, as I mentioned, we'll be using Next.js in addition to setting up some configuration files, so that way we can communicate with our backend team. Now, to showcase all of that sort of coming together, here's an example React component. What we have here is pretty much a home route, and you can see that we're taking advantage of state by setting up, in this case, a chat application, which has several rooms that can be established, and each room would, of course, have a room name. Now, we have a hook here called useEffect. That is going to make a call to our GraphQL server, which is provided by our backend, and in this case, we're simply going to query for the room data. And then towards the bottom, you'll see that we have the ability to sign out as well as say a message to the user once they load the screen. In this case, hey, and then whatever the username is. Now, what may seem different is that those components at the bottom, that button and that text, those are UI components that are pre-built, meaning that they have opinionated styles that you can also override. So that way you don't have to recreate and override all of the base HTML that you may be accustomed to. So moving on to our backend, and really discussing some of this backend tooling, we have three core options that AWS provides. We have the AWS CDK, where we have a developer-focused infrastructure as code scenario that really takes advantage of languages that front-end developers and back-end developers know and love. Languages such as TypeScript. You can also develop in Java, Python, etc. And the way that it does so is by encapsulating a lot of the AWS services and wrapping those CloudFormation templates with predefined and opinionated methods of engagement. After that, we have AWS SAM. And this is really suited for serverless applications. SAM stands for the Serverless Application Model, after all. And this is a templated abstraction where you typically define your templates in YAML and is an abstraction over CloudFormation. Same with the Cloud Development Kit. And then next we have the Amplify CLI. And this is a front-end developer-focused abstraction over the command line. And this gives us also the ability to extend our front-end tooling with either CDK or with CloudFormation itself. So you sort of get the best of both worlds when working with the CLI if you are a front-end developer and wanted to have your entire application built into the same project. So in this tech talk, we're really going to be focusing on developing our services with the CDK. And in particular, we'll be using TypeScript to do so. As we see in this image example, this is what it would take to create a DynamoDB database. You have encapsulated data, and again, these are called constructs within the CDK. Now, if you're a front-end developer, you could look at this and still understand what's going on because oftentimes those front-end applications are built themselves in TypeScript. Now, although it's not showcased in this example, if there are properties that aren't available within the CDK, you always have the benefit of falling back to CloudFormation and constructing those yourselves. And then by having this within a code base, one of the core benefits of infrastructure as code in general, we can put this in GitHub or code commit, so that way we can reference iterations as we move along. So when we're building out a full stack application, a modern full stack application, what are some of the core AWS services that we really want to take advantage of in doing so? Well, the first one is probably going to be a way for our users to sign in and sign out and otherwise authenticate in our application. Now, because we're working across stacks, we have to think about two models here, or two methods of engagement. Front-end developers, they just want a way so that way they can get set up with authentication in the application. In doing so, AWS Amplify provides a with authenticator higher order component. And as you can see on the first image, we simply wrap our existing application. Now, on the back end, we can take advantage of Amazon Cognito as well, but we'll have to be in charge of creating it. And this is what it would look like to create, in this case, a user pool. We have our stack set up, and we pass in various props, essentially within this object, to let it know what kind of engagement or what kind of interactivity we're looking for in our user pool. For us, we want our users to have the ability to sign up, and we do want to go ahead and send a confirmation code once they do get signed up. And as you can see here, one of the core attributes is going to be their email, in which case it is required and they are able to change it afterwards. Now, moving beyond our traditional to-do app applications, once again, when it comes to building out modern full-stack apps, we're going to take advantage of file storage. After all, a lot of applications need a way to upload and download files. So on the front-end side of things, Amplify provides a suite of JavaScript libraries that you can take advantage of. These handy utilities abstract a lot of the interactions that you would have to do by yourselves, either within a Lambda function or via the AWS CLI. In this case, when it comes to getting an image from Amazon S3, we simply pass in a key and it returns for us a signed URL. Now, these methods also take in a set of configuration options in case you want to fine-tune the access level from there. Now, as we can see here, still on the front end, we have the ability to add files, remove them, list them, and we also have the ability to copy files from one destination to another, keeping in mind the 5 GB limit that you would do on the front end. On the back end, once again, we're in charge of creating this bucket. So using a construct, as you can see in the highlighted text here, we have the ability to specify the removal policy. And once this bucket is deleted, in case you're in development mode, you could automatically have all the objects removed simply by specifying true as the auto delete objects key here. Now, creating the bucket is one part of it, but as a lot of us know, we also have to manage the permissions. And this is where the CDK really comes in handy because we can take advantage of for loops and iterations so that we can create these on the fly. Now, what you see beneath this bucket creation is an example of creating a policy. This policy essentially says anyone is allowed to gather public items from this S3 bucket. And this policy can be managed and attached with a Amazon Cognito identity pool if that were to be created as well. Now for this next piece, we have AWS AppSync. We're going to spend a little bit more time on this because it is a core piece of many applications. In fact, it is the API that drives the engagement between the front end and the back end. So when we talk about AppSync and its managed pub sub integrations, which we'll see an example of in just a moment, really what we're talking about is a managed GraphQL API, meaning you don't have to set up the server or manage the connection points. AWS will handle all of that for you. On the front end, we have the ability to automatically have the code generated so that the front end can interact with the back end. And that code belongs to the front end, meaning they have the ability to update and modify it based off of whether they want to solve for that overfetching or underfetching scenario. They can simply grab the data that they need. And then when it comes to querying for the data, those are abstracted away in these handy utilities provided by the JavaScript libraries that we discussed earlier. So in this case, we are querying for the rooms within our API. And then we also have an example of creating a message. So you can see this chat application starting to take form where we can pass in variables. And if we're creating a message for a specific channel, then we would want to pass in the room ID as well as the comment as well. Now, on the back end, going with the central theme here, you are in charge of creating this API. And it couldn't be simpler. We essentially define that the GraphQL API needs to exist. We give it a name. We give it a path to the schema. We'll see an example of that shortly. And then we also tell it what kind of authorization mode we want to default to. Now, note that we can have several authorization modes within our application, but this is simply the default. And this is all it would take to create the API. Now, talking more in detail about what's happening here. When it comes to the front-end applications, they don't just want a way to provide CRUD operations for their consumers. They also want a way to subscribe and have real-time data flow throughout their application. And then in addition, we also don't want to have memory leaks, so we need a way to cancel those subscriptions as well. AWS Amplify, using its JavaScript libraries, gives us a way to do just that. We simply pass it a query, which is going to be a subscription that is automatically generated via that command that we just saw. And then the front end is in charge of doing whatever they want with that data that gets received. And then on the back end, they can create that schema. Now, what we're seeing here on the left is going to be an example of a query and a mutation being created in the highlighted section. A couple points to note out is that the query section has two sort of abilities that are being unlocked here. We have the ability to get a to-do in this case, in which case we want to provide the ID, which would be unique, and it would return a to-do object, as you can see is being created below. Now, what we see next to this to-do on this same get to-do line are going to be directives. We have this AWS IAM directive, and what that essentially says is you have to have the correct IAM permissions to access this get to do. This can come in the form of a user, whether that be authenticated or unauthenticated. And it can also come in the form of an AWS service that has those permissions applied. Now to go a step further and look at some of the other integrations that we have AWS Cognito user pools. This directive essentially says you have to be authenticated within the application to take advantage of this get to do. And it automatically is searching for that JWT on the user token provided by a user that is successfully signed in. Now we can also look at our mutation where we have the ability to create a to do. Following the GraphQL spec, we have an input That special type in this case takes a to-do input, and we have our fields that we're expecting someone to pass in. Now, on the back end is where we really get to experience how powerful AWS AppSync is, because on each particular field, we have the ability to specify how that data is going to be resolved. Now, these resolvers take in a data source. In our case, we have a DynamoDB database, and the first highlighted resolver is going to map to this get to do portion of our schema. GraphQL follows a request response model. What that means is that as a incoming request comes in, it needs to know where to get that data from. And then when that response comes back, it needs to know how to show it in a way that AppSync can understand. Now, fortunately, when working in the CDK, there are a number of handy utilities that you can take advantage of to make it so that you don't have to write the underlying language, which is VTL. Now, velocity templating language isn't entirely difficult, but it is an extra step, and it is fortunate that a lot of these handy utilities exist. Some of them include automatically having the result parsed back in a way that AppSync can understand. And then as you can see in the subsequent resolver for the mutation, we even have a way to automatically generate IDs and pass those along as well. All right, so now that we have that taken care of, let's run through an example and see what a full-scale chat application looks like when we have real-time data flowing through it, as well as the ability to upload files using S3. All right, so with the application pulled up here, I have two browsers. Now, on the application on the left, I have a user that is already signed in and authenticated. Now, on the right-hand side, I have someone who is joining our application for the very first time. So what I'm going to do is I have this user here, MT Leendo, and I'll create a channel so that way we can go ahead and chat. Now, this room is going to open up a space where we can have anyone join as long as they are authenticated with my application. And to show you what that experience would look like from someone who is already set up, I can sign out of our app and type in their name here. Once I sign in through the application, I'm taken back to this home screen. So let's go ahead and create a name here, and we'll just say this is going to be for all of our Tech Talk attendees, and I'll hit enter. You see that this name has shown up, and I can enter the chat. There we go. Now, using the Amplify UI components, I have the ability to open up this menu here and view any of the application rooms that are there. In addition, I can select a file from my file system and have that display in the chat as well. So what I'll do in this other browser is create a brand new account. This will be my alias, which I often go by as Focus Otter, a super secret password that is then confirmed. And then I'll just give it a test email. Now, I also have the ability to specify attributes where I can list my full name, last name. If you wanted to collect other company information, any of those Cognito attributes will be able to be passed through. All right, so once you get signed in to the application, or rather you get authenticated with the initial step, we do have the ability to specify one-time passcodes. Now, I just got mine emailed to me, so I'll put that in here and then hit confirm. Now, notice what we have. We have this Tech Talk channel that has already been created. I can join that. And again, that was created by a previous user. And then because we are on a slightly different resolution size, we have our talk listed over here. Now, if I were to squeeze this over to the side, you can see it gets responsive and goes away, as you would expect in pretty much any application that is modernized and responsive. So let's get some messages going. I'm going to increase the size just so we can see it here. Now let's go ahead and get a message sent over to our users. And for the very first message, I might as well say hello world. Once I click send. All right, so I went ahead and got a hello world message set up. And I set it up so that the avatars that are specified simply make a call to my GitHub URL. So I don't have one for Focus Auto in case you're wondering why that's not showing up. Now, I can go ahead and send messages back and forth pretty easily here. So I can say, still on for dinner. You can see that message happening in real time. So as you can see, we have a couple messages that can be passed through. And we also have the ability to paginate through these messages if the screen were to get too long and flooded with additional messages. Now, because we are also persisting this in DynamoDB, I do have the ability to refresh the screen and still have those messages show through. So what I'll do is I will refresh the screen and then send another message here. Okay, so there's our message, and let's go ahead and hit send here. Okay, and as you can see, this hello message went ahead and showed up on both screens. So we do have the ability to have messages displayed in real time, in addition to having images displayed by selecting them in our S3 bucket and then hitting send to have them displayed onto the subsequent screen. So I can drag an image over here, and as you can see, it got recognized, and then hitting send will have that displayed. Okay, so with that demo complete, you saw how easy it can be to have independent stacks really scale at their own pace. So we have our front end in addition to our back end. Now, our front end had the ability to take advantage of amplified UI components, and our back end has the ability to scale with the AWS CDK. So with our front end having the ability to pull in our backend services and make use of them via those AWS amplified JavaScript libraries, now they can scale independently without having to worry about round trips with the backend team. So in terms of some of the takeaways, you saw how front-end teams can leverage the UI primitives and amplified libraries to scale independently. Meanwhile, backend teams can develop all of those services on their own, and they can be consumed by other teams and not just limited to just one specific front-end team. And then in the middle, we have AWS AppSync, which provides first-class support for Amazon Cognito, which we saw with authentication, then also integrates with other data providers such as DynamoDB and AWS Lambda. So that way data can be persisted inside of a real-time database. I want to thank all of you for attending this session. Once again, my name is Michael Liendo, and additional resources are going to be linked within the talk description. Thank you.